On today's show, learn the design principles for residential HVAC contracts. Now, there are certain principles we must follow when designing an HVAC system for our homeowners. Lucky for you, we have the master, Mr. Drew Cameron, and EGIA member, Eric Kelsis, to guide us through it all. Take it away, guys.
Number one, what questions to ask? And the questions that you'll see in this particular document are questions that you're going to ask of the house, of the customer, of the house, and of the system. I don't care how the questions get answered. One of them is going to tell me what's going on here. But these are the types of things that I'm looking for and the things that I'm measuring and taking pictures of and gathering data on. And again, for time purposes, I'm going to just let you see that we've got this 36-page document that walks us through the entire process. What to look for as you're talking to the customer and asking the customer, and then what to look for as you kind of walk around the house. There's some stuff on indoor air quality specific questions in here, as well as comfort questions were prior to that. And then it's like, okay, how do you perform the engineering analysis of the house, right? What do you look for? What do you measure? What are you gathering data on? And then you go down a little bit further, and we've got a whole document on, again, so this is also so that you can do your load calculation, by the way. And we got this other document, tells you where to look for other problems here. It's just an outline. And then it says what to look for once you get to the equipment as well, and the ductwork and gathering all that information. So 36-page document there. The questions that I extracted from that are ones I typically like to ask the customer are listed here. There's about 88 questions. No, you're not going to ask 88 questions. Sometimes the way a customer answers a question kind of, will dismiss asking other questions, or sometimes you ask them one question and they kind of go on a soliloquy and a narrative, and they answer like 10 questions for you, right?
That's pretty common.
Yeah.
It's more common than not.
And the key to that is doing what Eric said. It's listening, it's paying attention, it's being present and fully engaged with the person that's right in front of you, actively listening. And I teach you a listening skill when you come to the Elevated Consumer Buying Experience training. You need to take the notes. You can't ask a question and they go on this little narrative, and then you basically ask another question that they've already answered in the narrative because you weren't paying attention. Right? That just shows customers that you didn't value what it is that they say. So we basically take notes to show customers that we're valuing what they say, capture that information. It allows us to, and again, they're just cryptic notes. They don't have to be full, you're not writing out War and Peace notes here to write a novel. Cryptic notes that you can refer back to that will also, and I always like to put a little star or question mark next to something that basically I maybe want to follow up on a little bit more detail as I walk around the house. Because again, some of this questioning takes place when we're sitting down at the beginning, maybe at the kitchen table or in a living room, right? And then that's going to lead us to go on the tour of the house,
right?
And then looking at the equipment. So again, we teach that process in the sales training class.
They have an attic.
Yep.
I always crawl up in the attic. The harder it is,
that's going to be next. We're going to talk about that next.
The harder it is to get to that area, the more important it is to get to.
I love that. I love that. Okay. Now, do you happen to wear the jumpsuit? Do you put on a jumpsuit when you go to like the attic or the crawl space on?
I have, but I tend not to.
Okay.
I carry it with me.
Yeah.
I also carry booties with me.
Part of this game is the show, as you know.
Yes.
Right? And so we obviously put on the shoe covers, what we call the floor savers, right? We're protecting our floor. But if I'm going to go into an attic or a crawl space, I'm going to go get the full Tyvek suit, right? Because again, we're going behind the scenes. We're going all Geraldo Rivera investigative reporter here, and I'm going into some dark, dank, nasty areas. And again, I'm worried about my health, right? I don't know what's there, and I don't know what I'm going to encounter. Ever encounter any critters?
Yes, I have.
Okay, live critters, I'm saying.
I have taken a flashlight and shown it, and you see 6, 8 lights, eyes
eyes
looking at you. It's like, not going
Not
there.
going in there, right?
Yeah.
You have to call pest control before I go in there, right?
Yeah, it's. I've seen snakes up in attics. I've seen squirrels,
Snakes, mice, rats.
Oh
Yeah.
And
Dead cats. I've seen dead cats. We saw a dead possum yesterday in that one picture.
Yeah.
Yeah. I've seen all kinds of nasty stuff. And so yes, I'm concerned about my health.
If they got fecal material, I'm putting on a gown.
Yeah. So put on the Tyvek jumpsuit, right? And then you put on a respirator, maybe even goggles, right? And some latex gloves, and you go, full commando into the thing. And you're basically, crawling the crawl space and crawling the attic and whatever, or going in the, basements are not as bad in most cases, but it's crawl spaces and attics that I'm going to do that for, because again, I want them to know that your house breathes uncontrollably, and whatever there unless it's sealed, is going to be in the air that you breathe. So moving on here, you're also going to get a survey. I've compiled all this into a booklet here that you can use. Some of you are doing things digitally, but here's a multi-page, 16-page booklet that you can kind of, go ahead and choose to break apart and customize. Answer your questions, make some drawings, gather some detail, measurements, all kinds of good stuff here. So you'll get all that in the packet of information that we're going to send out to you here. But I'm not going to go through that today. It's pretty self-explanatory. But anything that you get that you have questions on here, you can obviously always reach out and contact us, and we'll be happy to help you out. So we go from the living space, and we then go ahead behind the scenes, right? We go to the building envelope and the system application. They're usually, in most cases, one and the same, right? I mean, obviously, as we're walking around the house, we're looking at the windows, the doors. We're figuring out what we believe the insulation factor to be in the wall. I gave you some guidelines in the material as to kind of how to guess it based on when the house was built and what the kind of the codes were. There's no absolutes nationwide on these codes or even all the way up into Canada, but they're guidelines. I mean, they accepted certainly energy and design principles in certain decades that houses were built. So use those as guidelines, but don't allow what we've shared with you to shortchange you doing a full, thorough, detailed process, right?
Yeah, if I'm on an outside wall, I'll take a tiny screwdriver and take off a switch cover, and then I'll take my flashlight and take a pencil or something and reach back there and see if I can find something.
Yeah, look for where maybe a hole. I mean, you can ask the customer, hey, you haven't a set of the blueprints from when the house was built, and then what have you done to enhance the house as far as insulation, windows, doors, skylights, additions, maybe finished a basement, finished an attic or something like that, finished a garage, turned that into a man cave, and find out what it is that they've done to enhance the space. You'll see that is listed in the questions, as well. And but a lot of times I can go peek behind a cabinet or ask them if they've ever happened to have a wall open and noticed how much insulation's in the wall. The reason I do this is because no one else is asking these questions. Do you happen to know what direction your house faces? I have Google Maps. I know what direction the house faces. I can pull out my life management smart device here, right, which is your cell phone, and figure out with a little compass. But that doesn't matter. It's about engaging the customer, right? And they say, well, why do you need to know that? Well, the direction that your house faces obviously determines what direction the sun comes up and the sun sets, and the exposure to the windows.
It's a big thing.
And we need to factor that into the load calculation.
Right. Because if you've got a lot of south glass, you can add another 2-3 tons to it. You
could take a house, and I know you know this as well. You can literally take a house, right, that is facing east and west, right, meaning it faces east. It's getting the morning sun. Sun comes up over the house, goes onto the back of the house, gets the west sun in the afternoon, right? I can take that same exact house, and builders do this, right? They build a Winchester model all over the community into development, and they rotate this thing, right? They do the mirror image of the house as well. And by just rotating the house 90 degrees, so that we don't have, we have a north-south exposure now. What do you think the tonnage changes by?
It can change a bunch. It depends on that.
About a quarter to a half a ton at least, right?
I've seen even 2 tons.
Really? Okay.
Yeah.
I usually find by rotating a house, about a half a ton is pretty much,
another ton.
Pretty much at least, half a ton to a ton. Yep. And so again, you can't just go by square footage of the house and some random rule of thumb. Although I'm giving you that information to you in the packet as a guideline. It's a check figure for you. Again, if you're ever having a conversation with a customer at a home show, or on the weekend, or you're impressing some of your friends at the bar, and you want to kind of tell them what size heating and air conditioning they have based on the square footage of the house. Again, you can use them as guidelines, rules of thumb, but math, facts, science, and data prove what it is that you're finding and recommending, right? So what else do you look for when you go, let's say, up into the attic, into the crawl space, into the basement? You're behind the scenes, right? And you're looking at the application.
I look for attic fan. I look for can lights. I look for knee walls.
Knee walls. Talk about that real quick. Knee walls. What are they? So for some of the people that don't know what a knee wall is.
So if you've got a short wall, somewhere it's 8 foot, and then next to it it's 10 foot.
Like in a Cape Cod style house, right?
Okay,
So you got a 4-foot wall, and then we get the slanted ceiling, right? Where the roof deck is right on the joists.
Right.
There's no attic space above it.
So your second floor or third floor is smaller than the floor underneath it. So it's what I do is I take a piece of foam or something that has an air barrier so the pipes don't freeze.
Okay.
And that I can cut down the infiltration sometimes 40-50%.
Right. But an outside wall, let's say, for example,
that is an outside wall.
It's an outside wall, but A regular outside wall on like the first or second floor, let's say it's 70 inside the house, right, on a summer day, and we're sizing for 95 outside. So that wall is basically treated as a 95-degree wall.
Correct.
What about the knee wall? Is that going to be 95 degrees?
If you do a super attic or a
let's say most people don't. What is that wall going to be treated like?
It's an outside wall.
But what's the temperature on the other side of that wall? If it's on the other side of a knee wall.
If it's up in the attic in the summertime, it could be 150 degrees.
So don't you have to treat that differently in the software?
Absolutely.
Yeah, you got to treat a knee wall differently.
Yeah.
So again,
in the wintertime, it could be negative 20 degrees.
Yeah. Yep.
And I've seen attics to be colder than the rest of the house because of nocturnal cooling.
Yep. So keeping that in mind, you're looking behind the scenes and gathering that information. And again, these are the types of things in detail that are explained in the document that I provided to you. We're also going to, when we look at the equipment, we're going to look at the configuration. We talked a little bit about this yesterday. So the configuration is basically looking at upflow, downflow, horizontal, right?
Where the ductwork is. I try to bring the ductwork in the building.
Okay, talk about that a little bit.
Okay, so you've got—
more often than not, it's outside the living space, outside the conditioned space,
right? And you can get ice damming.
Okay.
If you've got too much piping or too much ductwork.
That's a term that I don't think a lot of our viewers know. Talk about what is ice damming.
Ice damming is where in the day when the sun comes, it will thaw out the snow or the ice.
Snow on the roof.
On the roof.
Okay.
And then the building will heat it up again.
Yep.
When the sun goes down, it freezes up again.
Right, because there's air coming out, right?
There can be.
Yeah, and so there's basically what it's doing is it's not only it's freezing over the gutters, number one, but number two, it's then doing what at the edge of that roof.
Yeah, frequently you don't have a lot of insulation.
Yeah.
Right at the peak where you have a roof hits.
Yep.
And so right there.
What would be the evidence that someone would see that's evidence of ice damming? What would they see outside?
You actually can see shingles that come up, and on the inside you actually see water spots.
Yeah. So you're basically seeing damage because of the ice damming.
Yeah.
And so what would be the solution for that? I know a lot of our HVAC contractors don't do that stuff, but
you encapsulate the ductwork.
You encapsulate the ductwork.
Right.
Yeah.
And that's why the duct sealant, the 181 is so
seal the ductwork. Make sure it's insulated.
Yep.
Right. And then somehow through insulation or something, try and isolate it from the unconditioned space in the attic. Even though it's still, you mentioned this yesterday, right? Even though it's still in the attic, you basically are burying it in insulation.
Yeah. An R30 over the ductwork is not uncommon.
Yeah.
That's right.
And so in essence, it's like, again, you're just doing insulation, but you've changed and differentiated yourself, and you're standing out, and you're helping the homeowner see that, again, ice damming, the damage that is done, inexpensive to fix, right?
Oh, I've seen the one house I was working on. In a 10-year period of time, it had 7 roofs.
Right. So not inexpensive.
And the roofer kept on saying, I can't find the leak, Eric. I can't find the leak. And I said, well, it's not the roof, dude.
Yeah, it only reveals itself when there's this condition, right?
Right.
Because the ice is basically expanding and lifting the roof up and separating shingles. And
this particular house had 134 can lights.
Wow. Yeah,
and
that's significant.
The heat from the can lights, because she hardly ever turned them off, and she didn't like the looks of LEDs, so she used incandescent bulbs,
which give a lot of heat.
Yep. Yeah, and so you have 25 CFM for every can light, and in this one area overlooking,
because houses at the top are basically the air is leaking into the attic, right? So you've heated the living space. That heated air is now coming up through the can lights up into the attic and created, in essence, somewhat of a conditioned attic a little bit, right? It's not super warm, but it's still, according to the house feels it. You might not, but the house feels it.
And so she had a ductwork when they insulated the attic, supposedly.
Yep.
They knocked off the ductwork because they didn't fasten the ductwork to the starting collar.
Yep.
I think we all need a coach. I mean, I guess I look at Tiger Woods needs a coach for golf. and we surely need a coach for us around our business, help us run our business. When I talk to my coach Bob about different things, he's constantly giving directions on where I need to go, do some studying, and it's nice that it has all that stuff in the EGIA Contractor University. So
we've gotten a lot of really good advice. We're starting to implement some things that we weren't doing. We're unique because we only do ductless, so we have to kind of tweak the HVAC industry into our world, but we've been doing that, and with both Daryl's help and Bob's, we've been able to really rethink a few things, and we're starting to make some big progress.
The experience with Next Level Coaching so far has been really good. It's been really great to be able to talk about all things business, and even the social or the difficulties that we're enduring. It's not just KPIs. It's actually, it feels like it's human coaching more than business coaching sometimes.
I would say the biggest thing that I learned is about pricing, when I realized that I don't sell anything but labor. I control all my pricing through my kits, and that's where my labor is built in. And so it's made me more competitive because I'm not marking up big expensive items as much as I was, and yet I'm getting it all back from my labor. So it works really well. I'm getting paid for what we install and getting paid for what we service.
The biggest thing that we've learned from the Next Level Coaching would be the implementation process. So being encouraged on a regular basis to implement the things that we talk about, and to be able to go back and either look at the numbers or to talk to you where you remind us of where we left off, and to make sure that we're actually doing the things we said we were going to do.
Somebody else has already done this, and there are people who know how to do it. So go ask them and get the answers, because it's already been invented. You're not going to reinvent the wheel. You just have to tweak it to your company. And these guys have broad knowledge, and it just, they bring it in and they can make it work for you.
Do it. I mean, Next Level Coaching, if I could convince everyone to be a part of it, I think that's a big thing for us to all participate. We need to participate in every avenue that's available to us through the EGIA.
So we also have to take into consideration, obviously, we're going to take a look at the equipment capacity that is there, right? We're going to go read the plates on the indoor and the outdoor units and whatnot, gather the information. We also have to look at the dimensions of things, right? Because we have to, sometimes, I was just in a house last week or so, as well as the week before that. So I was in Virginia and Dallas, and basically to get the thing out first, right? It has to come out of the place. Sometimes you've come to find that they actually built the house around the equipment. And we found the customer last week, as I told you, we sold, customer had an oil furnace and an air conditioner. Guess what she had in the crawl space as well? The previous oil furnace. They just uninstalled it and abandoned it, right? And so when we got there, she said, yeah, they just abandoned it there. And it's not doing any harm, but we decided, hey, we're going to get it out of there because, ultimately we want to go back there and sell her get her to buy a crawl space encapsulation. Right. But we're going to dismantle that thing, uninstall it, and then obviously the new thing has to be able to go through the hole, or you're going to have to create access there. So as salespeople, you got to have a tape measure, okay? And if you don't have a tape measure, you will become public enemy number one of your installation department. So have a tape measure, utilize it. We're going to look at the duct system and the airflows we kind of talked about yesterday, right? And gather the information, all that. You got to crawl the entire duct system. See where it all is connected, see how it's installed, look for broken ducts, disconnected ducts. Again, a lot of the stuff you'll see in the survey packet as to where to look for these problems. You're looking for dampers, looking for the different types of supply registers. Do they have the right registers on there? They have air conditioning registers versus heating registers. Leaky ductwork, dirty ducts, looking inside, and taking pictures. Pop off the return grill and take some pictures inside there. Use a borescope or an endoscope to take pictures inside the ductwork. Again, like Eric said, make this thing visual to the customer. Because if it's just you talking about it, that's opinion. But having the pictures, having some drawings, having some notes, taking some tests is really going to help you.
Take pictures.
Take pictures, lots of pictures.
Yeah. And then if you have the customer's cell phone, simply tell what the issues are.
Yeah, you got to show them and give them a little bit of a narrative. Just sending a bunch of images to people doesn't make any sense. They don't know what the problem is. I know when you do your audit, you're basically, you're taking the picture, you're putting a little arrow to what it is, and then making a little note. But again, you're being paid for that.
Yeah, I'll get $600, $700, $800 to do a full-fledged audit.
There you go.
One system house.
Nice.
Yeah, and
nice.
But
and then you'll get the job anyway.
Well,
more often than
they'll
not,
put
right?
it out to bid. Then when you go to test it out again, and then you talk about all the problems that didn't get sealed.
Yeah. I know you wanted to talk about this when we built this class here. So we go into a house. It's had a heating and air conditioning system, right? Gas furnace, propane furnace, oil furnace, because this is where this particular issue happens, or it's a boiler, right? And so we've got to verify that we have adequate combustion air. And so combustion, right? So combustion air is air that allows the fuel to burn, right? And just because you inherit a situation and it's operated all this time doesn't mean, number one, that it's safe and up to code. You have to verify this. Now, this typically becomes an issue on combustion air when the equipment is installed in what is considered a confined space according to the National Fuel Gas Code, right? And so it's usually like when things are installed in a closet or a basement got finished after the equipment was already installed or something like that, right? So talk about, number one, combustion air, number two, venting, and then number three, I know a lot of our viewers don't get into the CAS testing, but I want to touch
combustion air zone.
Yeah, so talk about that a little bit.
Okay. I teach a class on this, and it takes me 8 hours to do this.
We don't have that.
So combustion air is basically on the older equipment. If you've got a 40, 60, 70% equipment.
Or 80.
Yeah. It takes a lot more combustion air.
Right.
You have primary and then you have secondary air. So the primary air that it takes to make it work can get huge. You can have 600, 700, 800 CFM of air for a large system. And then if you don't have it, then the flue is actually the makeup air.
Yep.
For the furnace.
So the guideline is, based on my understanding, is if I take these appliances, these gas appliances, which again, your oil appliances as well, and I take these open combustion appliances that are getting combustion air from the space itself, not like a 90+% of this bringing in the combustion air through the piping, right?
You can take an old 40% and
those stays of there, they're not going to really see.
But there's still a lot of them out there.
There's very few 40%ers.
You look outside, and I pictured when I was in the hotel, I pictured 7 of them in my hotel room. Yeah,
it's like that'd be a 50, 60-year-old furnace.
Well, they're out there.
Maybe. Okay.
So if you look at the flue and it's all nasty on the outside.
Yeah. Okay.
If you look on top of the roof, the flue is rusty and it's just nasty. And then yesterday I saw ice buildup on 4 of the 7 atmospheric flues from my hotel room.
Wow. Okay.
So
were those commercial buildings?
Yes.
Yeah, because obviously where we are, right?
Yeah. Right. But
commercial, this is residential.
When I took my walk, I saw over a dozen houses that had ice off the flue.
Okay.
And that's a call for action.
There you go.
Right. So that means the flue gas isn't getting warm enough.
Yeah, and we're obviously in a super cold climate. We've had a little bit of snow here, and so you're going to probably see that a little bit more in a place like this, and you maybe will in certain other markets. But
right.
But again, so for combustion air, the rule of thumb is 20 BTUs per cubic foot of input of the combined appliances. So for argument's sake or example's sake here, what we're talking about here is if I have a 100,000 BTU input furnace, 80%er that I'm going to put in because I'm not worried about the thing that's there. I'm taking that out and I'm putting in the new 80%er, let's say. That's 100,000 BTUs input. I got a water heater that I'm either inheriting or replacing. Let's call it a tank water heater. It's 40 gallons. That's another 40,000 of input for that water heater. That's 140,000, right?
The cheaper hot water heaters could be 32,000.
Could be, but I'm going to again. It's going to tell you on the plate, right? So you gather the information at the plate. You add the total combined input of those devices, and then you divide that by 20, and that's going to tell you how many cubic feet of air, free airflow space that we need for combustion air. And if I don't have it, then my job is to get it from somewhere. And the way I get it is usually put a louvered door on the closet or the utility room. That's one way. I can install ductwork or grills, transfer grills to the adjacent space. I can install ductwork to the adjacent space, or I can get it from the outside. There's also a device called a fan in a can. Right.
Turngeland makes one that's
Turngeland, TG Turngeland. It's like, is that like Swedish or French, Swiss?
It's Nordic.
It's Nordic. Something Nordic. That's right. You're So that being said, that's a way to do that. Talk about venting, right? So we get into the house, and we have the thing that we're inheriting that we're going to get rid of. We talked a little bit about this yesterday, right? And we're going to basically put in a 90%er, but we're going to orphan the chimney.
Then you have to put a flue liner down or something to make it smaller so it heats up quicker.
Which would makes zero sense, because what you spend for the flue liner, you might as well invest that into a brand new direct vent or tankless or heat pump water heater, right?
Frequently, it's the same cost to put a power vent PVC fluid hot water heater in as to put a vent liner in.
Yeah, and the thing is, you have to realize on tank water heaters, the warranty is typically only 6 years on a tank water heater, and so if they're beyond that, they're living on borrowed time as it is. Now, again, if you're at 10 years on a tank water heater, okay, you're like, you might as well go to Vegas or Atlantic City, because you're living on rolling the dice here with that thing leaking at some point. It's not a question of if, it's a question of when that thing will leak and how severe it will be, and the damage that will happen as a result, right?
Right. So I look at hot water heaters really, really, really heavy when I'm doing my walkthrough. And 80% of the time, I am recommending a power vent or a tankless hot water heater.
Yep. Water heater, not hot water heater. All right. So, and I was going to ask you, that's what this device is. Is this for what I think it is? For checking?
This is a flue gas analyzer.
Okay.
Can you do a close-up, please? And there's a lot of them on the market.
What did it do with this?
I put the rod into the flue, and I test the flue gas. I'm testing for oxygen. I'm testing for carbon monoxide. I'm testing for temperature. And if the temperature isn't high enough at the outlet of the flue, I know it's not going to be high enough at the top of the flue if it's atmospheric.
Yeah. And so especially if you put in something, if it's not working on the old 40, 60, 70, 80% efficient, 70% efficient furnace, and you go put in less heat into the chimney, it's definitely not going to work, right?
And the new hot water heaters, the pilot light is literally 1/8 of an inch tall.
Yeah. So does this device also check for carbon monoxide?
Yes, it does.
So do you walk around the living space and
turn
test?
on outside and I walk it.
Okay, but you also walk around the living space to see if any carbon monoxide's up in the living space too.
Yeah. Right,
because most homes should have a, I mean, it's coded in a lot of places that they have a carbon monoxide detector outside of each of the bedrooms, right?
Correct.
Okay, and again, let's talk about that real quick. Carbon monoxide detectors versus carbon monoxide monitors, right? The things that customer can buy at Lowe's and Home Depot and Costco and online and whatnot, those are carbon monoxide detectors, that they can get at retail. And like Eric said yesterday, those things start signaling anywhere between, I think about 60, 70 parts per million. That's so that they can get the UL listing, which is an electrical listing here in the States that makes it safe and certified, right? And that's a lobby for the, those organizations that have worked with the Washington to ensure that that's what gets them that UL listing. However, you're not supposed to be sniffing carbon monoxide even at low levels, 5 parts per million, 15 parts per million, 35 parts per million for any extended period of time. I've given you some information on this carbon monoxide testing and facts you should know about carbon monoxide. Just because you have a crack in the heat exchange doesn't mean you have carbon monoxide coming into the living space. But you need to understand the dangers of carbon monoxide and share that with a homeowner, not to fear that, put them in fear, but to make them aware. Anyway, you need to walk around the living space and test for this with a low-level carbon monoxide monitor. And then I basically talk about, again, even though you're putting in good equipment and you're doing it the right way, that doesn't mean that they still shouldn't have some measure, right, just in case something were to happen, right? An ounce of protection, right?
Yeah, I like using low level.
Whose do you use, CO Experts or NCI?
I'll use both. There's actually 6 manufacturers. Okay. And they're using the same sensor on every one.
Yeah, so you're going to get Eric's contact information if you're not familiar with low-level carbon monoxide monitors that you can sell to a customer so that they can constantly monitor for this, because again, maybe they start out the car in the winter and that carbon monoxide leaks into the house. Maybe they're cooking and they've got an issue there, or they've got a dryer issue, things that you haven't touched, causing carbon monoxide issues. And so
1 out of 11 houses have very high carbon monoxide.
Yeah, even some of the hotels you go into. I remember Jim Davis at National Comfort Institute went to Comfort Tech in Atlanta in 2000. I think it was like 2001 in Atlanta, and he was at the top of the Omni Hotel downtown Atlanta after a storm had just come through and damaged a lot of the plate glass in the hotel, and they were replacing the plate glass. And again, he was teaching a class at the hotel at Comfort Tech for this event, and he travels with the monitor, has it in his car, it goes off in the car when he drives through tunnels and stuff like that.
It's on his belt.
It's on his belt. He walks around with this thing. He actually has a personal one. You can even get a personal one that you can kind of walk around with, and your technician should certainly have those as well. Anyway, quick story is he went into the hotel. He's at the top of the hotel, and they're replacing the plate glass windows at the top of the hotel, and the signal goes off in his carbon monoxide monitor, and he goes to the front desk and he tells the manager, hey, you need to stop all construction right now. You got huge amounts of carbon monoxide pouring into the building through the elevator shaft.
Right.
And he goes, you're going to possibly make a lot of people sick or possibly end up killing somebody. And he proved it to them. They shut down the whole project until they could find a way to ventilate the thing. True story.
So it's the stack effect. The trouble was the boiler was feeding through the elevator shaft, this stack effect.
Yep.
I was there.
So again, we want to, obviously letter D, we want to look for this evidence of this stuff as we kind of go along here, but in letter E, we're going to go ahead and understand the issues. I've given you some information that you also have to make sure that if you're going to go ahead and do anything from an electrical standpoint, that the panel can handle what it is that you're doing. The wire, the breaker sizes is adequate there. Some cases, depending on if you're adding air conditioning, you're doing something in the attic, you may have to install lighting and switches and outlets in order to basically allow this thing to be serviceable and whatnot. That's all dependent upon local codes. So make sure you're licensed and permitted to do the work that you're doing, or that the subcontractor that you bring in is as well. Again, I want to sprint to the end here before we take a break here. Gas piping, Eric, you talked about this a little bit yesterday about making sure that the gas pipe size is adequate for what you're doing, but also from a pressure perspective that you're setting that up properly. Now, for you salespeople, that's not really your responsibility per se.
If you walk into the building and you smell the captain, the gas smell,
you
know there's an issue, and you need to act on it.
Yep.
And if you don't have a way to test it yourself, get a tech who can.
Okay. And you have to also, if you're going to do conversions, right, oil to gas or gas, oil to propane, oil to propane or oil to electric or gas or propane to electric, what do you got to take into consideration there? Again, go back to the list above, right? Is it the venting? Is it the electrical? What are the safety issues you got to take into consideration when you're uninstalling things? Another thing you have to do in a lot of places, right, is if you're going to reuse a chimney and you went from a solid or liquid fuel to a gaseous fuel, you either have to line the chimney or sweep it. Do you run into that anywhere where you are?
Not too much.
Okay. I know where I was in Pennsylvania and Delaware, Maryland, and New Jersey, we would have to bring in a chimney sweep or line the chimney if we were going from oil to propane or oil to natural gas, because the creosote would line the chimney, and that creosote is flammable. So these, again, are all kinds of things that from a code perspective and just a technical perspective that you need to be aware of as a salesperson, so that when you go in there, you're using your eyes, and again, pictures, drawings, video, and things like that, to gather your information.
Awesome content right there, as always. Now, if you like this content, please share it with your friends on Facebook. And if you're not a member, go ahead and click the button below to get a free 30-day trial of our entire Contractor University platform. We'll see you next week. Until then, my friends, bye-bye for now.